LeetCode problem 2148. Count elements with strictly smaller and greater elements. This is a recently added algorithm problem of easy difficulty, and we are given an integer array nums, and we want to return the number of elements that have both a strictly smaller and a strictly greater element that appear in nums. So in this problem, we have an array, and we want to return the amount of numbers that are not the greatest or the smallest element in the array. So my first thought was basically just take the length of the array and subtract 1 for the smallest number and subtract 1 for the highest number and just return that. So like in this case, we have a length of 5 and we want to get rid of the 4 because that's the smallest, and we want to get rid of 15 because that's the biggest. And that leaves us with an array with a length of 3. And that's going to be our answer. Pretty simple, except if we are given an array that has the same value that appears twice that happens to be either the smallest or the largest, then we can't use that simple solution. So right here we have 4 that will be the lowest number, but it appears twice. So we're not going to want to include that. And we also have the 15, which is the largest number, so we're not going to want to include that. So that makes this a little more difficult than this first solution I came up with. Uh, so how are we going to go about solving this? So the first thing we want to do is figure out what the smallest number is and what the largest number is. And we can do that by setting variables for the lowest and for the highest. We can use the spread operator to spread the nums array, and then use the math.min function to find the smallest number, and then we'll set that to low. And again, we'll spread the nums, use the math.max function, and we'll set that to high. So now we have our lowest number set to a variable and our highest number set to a variable. And so to get the number of elements in this array that are not equal to low or high, what we can do is we can create a counter. So we'll just create count over here. And what we're going to do is we're going to loop through the array, and we're going to check to see whether or not the current index number is not equal to low and not equal to high. So we can use a conditional as we loop through. If nums I does not equal low and nums I does not equal high, we're going to add to our count. So let's run through this first example. 11, or we're going to set low, and math.min will return 4. And then we're going to look for high, which is 15. So we're going to set that. And then as we loop through the array, 11 does not equal 4 or 15. 7 does not equal 4 or 15. 8 does not equal 4 or 15. So now we're at 3 for our count. 4 does equal 4 or 15. 15 does as well, and so does 4. So that will give us the answer 3 that we are looking for. So that does it for our diagram. Let's try typing this in code. So we want to start out by setting our low and our high variables. And as we diagram that out, we want to use the math.min and math.max functions. So we have let low equal math.min. We're going to use the spread operator on the nums array. Then we want to get our highest number. So we'll set that to high equals math.max on nums as we spread it. And we also want to instantiate our count. So we'll set count equal to 0. And at the end, we want to return our count as our answer. So we're going to start our for loop. We're going to set I equal to 0, I is going to be less than nums.length, and we're going to increment I at every pass. Now we're going to want to use our conditional that we used in the diagram to check whether or not the current iteration of nums is equal, or in this case, not equal to low and not equal to high. So we're going to say if nums I does not equal low and nums I does not equal high, we're going to want to increase count by 1. And that's it for this code. I am going to run this with the test cases and see if there's any mistakes. And it comes back as accepted. So this is pretty good. We don't have to use a loop. And in fact, we don't even have to use a count. We can refactor this into a more streamlined solution using the filter method on the nums array. So what I want to do is remove this loop and then remove this count. And we're going to set a result array equal to nums.filter. And what we're going to do is filter out all the values that are, or we're going to filter for numbers that are not equal to low and are not equal to high. So we're going to say I does not equal low and I does not equal high. And what we want to return is just the length of the new result array. Let's run this with the test cases. And this also works. And if you want to refactor this even more, we don't really need to set this to a value or a variable. We can just put the length. We can pin it to the back of this filter method. And we can just return it right here. This is just going to return the length of this newly filtered array. And I'm going to run it with the test cases. And it works. And I'm going to submit it now. And we get a successful message. Some good runtime, some good memory usage. If you want, you can actually get this down. You can refactor it to a one-line function. I'm just going to leave it as is and let you try and solve that for yourself. I will include the answer, the one-line answer, in the GitHub repository if you want to check it out. And as always, if you have any questions, if you have an answer of your own, or if you have improvements to my code, please leave it in the comments below. And thanks again for watching.